This is a classic experiment. If your parents took chemistry, it is very likely that they did an experiment similar to this or this one. So in this experiment, we are going to try to find what is the formula of copper oxide. Now, as you all know, copper comes in two forms, either copper 1 or copper plus 2. Depending on which form we're using, the chemical formula is going to be different. For example, if it's copper plus 1 and it's reacting with oxygen, then it's going to be Cu2O. If it's copper plus 2, it's going to be CuO. So the question is, the copper oxide that we're going to produce, is it cupric oxide, copper 2, or is it cuprous oxide, copper 1? Let's find out. What do we need? We need a crucible. This is made of ceramic and can withstand enormous amount of heat. We're going to weigh the crucible. Please record this number in your scrap sheet of paper. 31.63 grams. That is the mass of the crucible. You must know that mass. Here is the copper metal. It is in a granular form. You can see the color is there, but we're used to it being very shiny. But because it is in a powder form, it looks the way it is. We're going for surface area here. We want as much of this copper exposed to the oxygen in the air as possible. So we're going to add a scoop of copper to this crucible. 33.96 is the answer. So we now have the mass of the copper in the crucible. So that reading is going to be almost 96% crucible, and the rest is copper. The rest is what we need. Here is the tools that we're going to be using. We're going to be using a Bunsen burner, clay triangle. You can see there, you finally get to use a clay triangle with this experiment. And you have the crucible with the copper, and you will also have a ring stand. We need to get this Bunsen burner going, and it needs to be super hot. So notice the flame within the flame. We need this very tip to be hitting the bottom of that crucible, because that crucible is going to need to get very, very, very hot. So here it is. You can see the tip is hitting the bottom of the crucible. So we're ready to roll. This is what you can see. You can see it darkening as the copper reacts with the oxygen. What you're seeing there is copper oxide. If you look at around 11 o'clock, it is glowing red. It is so hot. Now, I'm going to let it cool off. Why? Because crucibles tend to, because they're ceramics, they tend to absorb a certain amount of water. So when we weighed the crucible originally, when it was cool, it had that water in it. So we weighed it with a little bit of water in it. Of course, when you heat up the crucible, that water evaporates, it goes away. But we need to let it cool so that the water will come back in. Because remember, we weighed it before the water evaporated. So that water, that original measurement had a little bit of water in it. We need to make sure that that water comes back, or else this reading will be less than it should be. So I let it cool down to where I could easily pick it up with my fingers without burning them, and now I place it in onto the balance scale. 34.56. You better write that down. So, am I done? The answer is no. Because how do I know that all of the copper has reacted? If some of that copper is unreacted, then my measurement is going to be wrong. So I think I've got it all reacted. It all looks black, but what if there's some copper underneath, or where I can't see, that has not reacted? So this is what I'm going to do. I am going to reheat it again, and I am going to let it cool off again, and then I am going to mass it again. Why? Because if I heat it up for, let's say, 5 minutes, 10 minutes, and the mass increases again, then that tells me something. That tells me that I did indeed have some copper that had not been reacted, and now that copper has gained the oxygen, therefore a gain in mass. But if I have no change in mass, as you can see here, then that tells me that I have now, I got it all. I got all of the copper in the first try. If I had experienced an increase in mass, then what I would have had to have done again is I would have had to have heated it up and massed it again. So you want to be patient with this. If you're too quick, you will end up having to work twice as hard, or you get bad results. Okay, so now we have this black substance, we have its mass, we're ready to determine if we have copper 1 oxide or copper 2 oxide. So what do we know? We know the mass of just the crucible. That was 31.63 grams. That's just the crucible. Once we added the copper to it, that's the mass of the crucible and the copper, and that was, if I remember correctly, 33.96. Now, if you take the difference between those, you get a difference of 2.33 grams. That is going to be the mass of the copper, and that's very important. Okay, what was the next measurement we had? The mass of the crucible, the copper, and now the oxygen with it. And it measured 34.56. So if we subtract the copper crucible from the copper crucible and oxygen, we should be able to come up with the mass of just the oxygen. That gives us 0.60 grams. That's all we need. Because what are we going to do? Well, a formula is made up of a mole ratio. So if we can get these grams and convert them to moles, then we have a mole ratio that could possibly get us to our answer. So here we go. 2.33 grams of copper was originally used. To convert to moles, we need to divide by the formula mass, which is 63.5 grams, and multiply by 1 mole. Because in 1 mole of copper, you have 63.5 grams of copper. You get an answer of 0.0367 moles of copper. The mass of the oxygen was 0.60 grams. Once again, we're dividing by the formula mass. And we get an answer of 0.038 because of sig digs. Only 2 sig digs. Okay, well, as you can see there, those numbers don't really help us. They are mole, and we can get a mole ratio from it, but according to the law of multiple proportion, which was proposed by John Dalton, we have to have simple whole number ratio. So, how did I teach you how to do that? Divide by the smallest mole. And that gives us 1 to 1.04, a number that we can easily round down to 1. So our formula is Cu1O1 CuO, copper 2 oxide.